Okay. Wait, what? Is it live? Okay, it is live. Alright. Yeah. Right. So what was going on earlier? Okay, I have way too many tabs. Let's delete that. Let's delete this. Delete that. Yeah, I was trying to load it. I was getting some error. Yeah, right here. Cross origin request blocked. So like right after I streamed yesterday, I think I know a fix. Like I think I have to actually like start up a local server and serve on localhost. Okay, so this tab is just the I'll just cut that so it's in my paste buffer. Error local. Server environment, right? GitHub URL. Okay, that's whatever. I'm just gonna delete a bunch of these tabs. I can keep that tab open. I'll keep this tab open. Train. Whatever. I'll just close that tab. I'll close that tab. I'll close this tab. I will close this tab. Okay, good. They're finally in the same row. Data. Let me just run it. Okay. I'll close this tab because I only care about this tab. This is a picture. I mean, good memories, but I'm gonna close you. Let me just actually. Yeah. Let me just look at my commits. Okay, so yesterday extract. Okay, yeah, that looks good. Let me close this tab. Close that tab. Okay, that's a bunch of good cleanup. I'll keep this tab open. Wait, no, this is whatever. Yeah, okay. Okay, so the issue I'm having is this issue right here, right? Let's basically continue where I left off. But first I should drink some, yeah. Why am I always cold? Yeah, like my feet and my fingers, extremities are always cold for me. What was I doing? Yeah, right. TF.js, local, okay, local model, cores. Okay, I've already seen this answer yesterday. More results. Oh yeah, okay, yes. Yesterday after streaming, I kind of thought that this might be the solution. I mean, trying to do a node, right? But then the thing is, I've already done this in Node, like in my test.ts file, like a few streams ago. Yeah, I remember. Okay, fetch. Fetch cannot access. Okay, so this Stack Overflow question is the question I needed to see. If only I'd seen this yesterday. But then again, I was getting pretty tired, to be honest. User upload the file. Yeah, I remember seeing like model.json and the binary file for weights. Okay, G is for global. I'll just do it locally. How come this is not accepted answer? What's accepted? Oh, none of them have green check marks? The poster didn't select one? Well, I will select, how come the most upvoted one doesn't even answer the question? Like, he literally, the disclaimer. Anyways, here. I mean, my game uses Express.js. Should I use I've never used this HTTP server. But I guess this probably, I've used like Express to like public static directory. Okay, I'll just try this. I mean, he has 18.1k gold stars, so, or no, 10 gold stars. Whatever, his reputation's pretty impressive. High elo. Alright, let's do this. Okay. Let me just cap my package.json. Okay, so I just have all these things. In fact, I think I could probably delete, just only have this, whatever. Let me just install that. Okay, now look at my, I'll look at this again. Now we have this server. All right, that is good. And then this right here. Okay. Boom. What? Do I have to install -g? Yeah, I think that's the question. And then these flags right there. Okay, now it is serving this directory. Right, because like HTTP server, like, which I was trying to do earlier, right? Like, I didn't install globally. Like, if you install globally, I guess like it'll go into your binary, like your some bin folder. But anyways, so it's serving it, right? So now can we like kind of duplicate this, but do like localhost instead? Or sorry, not that. Okay, the port. Oh, is it working? One. Oh, I could have. Oh, oops. Anyways, yes, 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 yes. You see these three requests right here? Miles.json waits.bin. Yep, this did it, right? Yeah, see, load layers model. Okay, this is a good place to commit my changes. Actually, I should add this to the run script, right? Yeah, let's do that. Control C to stop server. Okay, Control C, just to refresh to make sure it stopped. Unable to connect. Okay, so then let's go to my run.sh script, and then paste this command. Wait, what? Yeah, okay, so this thing right here, let's copy this and then paste it into there. Can you do like, what's it called, like echo? Nice. Okay, so here's our new run script, right? Oh wait, no. Yep. Okay. So again, I'm just gonna play a game with myself. Why is the bot playing so well randomly? Wow, he actually. Okay, that was a bit cheap, but I'll take the win. Okay, so right now the model is actually like can I put some breakpoints maybe? Actually, let's just look at us. Like, you see how this code has like 2,000 lines, like so many. like a lot of lines, because like browserify, like you see these lines right here, like buffer or whatever, like alloc, all these C sounding names, malloc, calloc, whatever, like all this stuff is TensorFlow .js, like bundled, because like we bundled it in. Yeah, Euclidean, wait, what? I saw Euclidean somewhere just now. Yeah, tensor, just all these anyways, so that's the point is wait, what is the point? Sorry, okay. I want to find like right. So bot.getMove, right? So I want to see like how this is done. So bot.getMove. Model, right? So this model is the TensorFlow model, right? Outputs. Rank 2. So that must be like, this must be the value, right? Length 2, whatever, yeah. And the other one should be 11 then, right? Wait, shape 2. Well, I'll not try to understand this right now. I'll just, okay, let's just, okay, I'll just remove the breakpoint. Okay, so right now, status, diff. Yeah, so now we're not using the file protocol, we're just like using the relative path, and then since we have a server, then this will automatically just work. Right? And then, okay, what else? Some packaging stuff. Okay, let me just manually do it. Get status, clear, get status, get diff, get diff game.ts. Yep, that's fine. And then we just did run.sh. Okay, get at all, get status. Okay, so now let's actually use the bot, right? Let's just use the model, because now like what we have done now is we have we're passing in the model, right? Like get diff staged game.ts. Let me just declare it and then do the same command again. So now what we're doing in the constructor is we're actually like giving the bot a model. So now we want the bot to actually use this model, right? And right now the bot, like, yeah. Again, if we do like ls, we see model, right? So we have to do ls model, and then here we go. The model and then the weights. And that's how it's done, right? So right now, we're actually loading up this model into the bot, but we have to use it. So let us use this, right? To do, let's query our model for move. Exactly. So we have a layers model and we have to actually use it. Right now, we're just kind of doing random, right? Okay, let us do this, right? Okay. For now, I'll just do console.print statements, right? So it's model.predict. Let's just call this like let prediction equal to, and then console.log prediction. Something like this, right? Add some space here, and then add some space there. Okay, something like this, right? Model.predict, and then how do we give it a prediction, right? We're gonna have to pass in the tensor, right? We're gonna have to pass in, if we take this game state, we're going to have to convert it to we're going to have to convert this game state to like a tensor, given like the player's turn it is, to like decide like which layer goes on top. Okay, let's do this in the net.ts file, right? So let's export this function, create model. So this net.ts is going to be like kind of utility class, right? So export function predict, or no, sorry. Well, what are you trying to do again? So what we need to do is first convert game state into representation net model can digest, convert it to input tensor. Okay, so then convert, let's call this convert export function, convert game state to because again, like convert game state to net to model input. Very verbose name, right? Game state is a game state. And then what does this function return? It will return a tensor, right? Well, for now, I'll just leave it here. I'll just not specify the return type because I'm not really sure if it. I have to import this function. How do I do that again? export function. What's default? A main export. No, but there's going to be multiple exports, not a main one. Import function name from the. Okay, perfect. So import. Yeah, that's what I was about to do, to be honest. So let's copy this function name. Right, okay. Let game, let input equal to convert of the game state, right? Okay, so that's where it is. Predict the input, right? Let me look at the input. Let me just look at an example of this again. Functional API, no, that's for overview. Actually, I have another thing, right? Let's let me look at the what do you call that? The test, right? Predict as tf.tensor, right? So I'll just take this, right here, tf.tensor, and then let me give that the return type, right? As tensor. And here for input, just to be very verbose, tensor. Okay, so let's see, the tensor, tf tensor.2d, something like this, right? So let's just copy this. Let me look at the documentation again. Tensors and operations. Okay. Central unit of data in tensorflow.js. TensorFlow is tensor. Set of values shaped into array of one or more dimensions. Multi-dimensional arrays, yes, okay. Matrix, just a multi-dimensional, yeah, exactly, multi-dimensional arrays. Rank defines how many dimensions. Shape defines the size of each dimensions. So it's like a generalization of a matrix. D type refers to data type. Okay. By default, yep, that sounds reasonable. 32-bit float. Rank 2 tensor, two-dimensional tensor. tf.tensor. Okay, so tensor 2D, right? tf.tensor 2D is two-dimensional. Okay, I guess tf.tensor is what we need then, right? tf.tensor method. Dimensional array. I really want to see what this print statement like actually gives you. In fact, yeah, for now, let's just focus on the input, right? Let's just focus on the input. So instead of prediction, let me actually, comment out these two lines. Let me just comment these out, and then console.log input. I'm just curious to like, I just want to like make sure we nail down the input right now. Like that's what like, let's just focus on that first, right? Okay, so we have to do it here. We have to actually like do the input. Okay. So then, okay, so actually I'm gonna open game state too. Let's do that. Not game state.ts. This is 1, 2, 3, the fourth one, right? So we can do a :4n to skip to the end. Oh, wait, what? 3n? Yeah, 3n, because we're starting off at 1. Okay, so then game state has a bunch of these cells, right? So, okay, fine. So then what we're gonna have, right, is 2 image stacks, right? So let's have, okay, so back here, right, we're gonna have to have like, okay, again, whiteboard. Create a new board. Right. So again, I feel like I've drawn this like 1,000 times by now, but like we're gonna have like 2 image stacks, right, for input. This would be a current player, and then that would be the other. So in this case, it is the bot, right? The bot. And again, like, and then like if you have like this kind of here, like let's say 3 right there, then that would correspond to like 3 right here. And then like, actually, wait, I have a better idea. Instead of that, what I'm gonna do is like put like 3 right here, right? Like 1, 2, 3, and then kind of like a block here. So what this would be is kind of like, let's say the bot has like that, and then for here, like you'd have kind of like a blockage to like kind of block it, right? The human. Like the bot's pieces and the human's pieces. Okay. So then you would have what are the dimensions, right? Like we'd have like 2, and this is kind of like the channels, or like this is like the number of image stacks. This is 2, right? 2 because like number image stacks, number image stacks. Like each of these are an image stack, kind of like RGB for like convolutional networks. And then what? Then like in given image stack, we'd have R for the number of rows, right? Number rows times C, the number of columns. All pretty standard. And then for each and then each cell is binary. It's 0 or 1. Like these are all like kind of binary entries. So there's no need for any batch normalization layers in the start. Like everything is normalized by default. Even in BumperCoins, the health is bounded between 0 and 1 for each coin. So it's already kind of like, it's already batch normalized. Like there's no need for any renormalizations in the beginning. Everything is kind of like bounded between 0 and 1. Everything is normalized to 1.0, which means full health. Okay, great. And obstacles, again, a binary value. like just a binary variable. Yep, everything's binary, everything's normalized. That's good to connect for. Okay, so then we have to build a tensor of 2 by r by c, right? Okay. Okay. So then we could have a helper function, right? Alright, let's get that. Okay, so then convert game state to model input game state, and then we have to also pass in a boolean, right? Like we have to like kind of tell like which one is for the bot, which one's for the human, right? So convert game state to model input game state, and then whose turn is it? Like is P1? Wait, no, the game state has that encoded in it, right? Convert game state to model input. Let's just put a comment of this function. This function uses game state dot, and then what is that? What's that? The is P1 turn, right? Game state is P1 turn, and returns input from perspective of player whose turn it is. Wait, doesn't that mean that like for this one, like we don't really care, like wait. Then we don't really need to pass in this input, right? Is P1 bot. Like the bot doesn't really, this becomes a bit redundant, right? Is P1 bot, because like whenever we're calling get move, like whenever we're invoking get move, it is the bot's turn, right? Like the bot when we're doing get move, then get move, like we're getting the move, we're querying a move, and we're passing in the game state, but in the game state, like we're doing it, like we're doing it for the player whose turn it is. That is, the game states, whatever, what was that called? Like the game states is P1 turn necessarily equals this boolean, right? Like let's just say that the game state that is P1 turn is true. That means it is player 1's turn. Then this bot has to be true too, is P1 bot. Because we're only going to ask the bot for its move on its turn. So I could delete this boolean, to be honest. I could just delete it. Actually, why do I even have a class bot then? When all we're doing is we're just simply, I could just like use net.ts like functions directly, to be honest. Bot is simply a thin wrapper around model at this point. Seems unnecessarily complex. I mean, maybe like in the future, like bot could be given some depth settings. Like we could have like a field here, like integer, like depth or whatever, like number depth. Where like not only like right now we're just like doing model.predict, right? That's what I plan to do. But in the future, we could actually run a Monte Carlo tree search at a specified depth. Like we can like give the bot members of like additional fields for like difficulty, some toggle to control the bot elo, the bot difficulty. Like we could do a tree search on this prediction. Like we could do Monte Carlo tree, so we could do alpha beta and just like use kind of like Stockfish versus Leela, right? Like Stockfish uses alpha beta tree search. Just a standard minimax tree, minimax with alpha beta pruning, right? A very classic technique. And then we can control like the depth size in that here maybe. So I guess having the class bot does hold some potential future merit. Okay, I've talked a lot. So let's actually like build this, right? We want to actually implement convert game state to model input. Okay, that sounds good. Sounds good. Wait, what? Right. So we have to implement this. Okay, I think I'm all out of coffee soon. Convert game state to model input. Okay. Perspective player whose turn it is. Let is P1 turn boolean equals to game state dot. Oh, I got the name correct. That is P1 turn, right? Okay. Or actually, no. Oh, sorry. Let's call this current player or okay, no, forget this. What we have to do now is like let's just like it's like right now, like the symbolic, like what is the significance of this, right? Let's first build this stack right here. Let's first build this, right? So we need all the coins that correspond to the current player, right? So let's do a current player cells, which will be an array of cells, right? Equals to empty. And then let's let other player cells equal that, right? And then for yeah. I just wanted to copy some code. Yep, this looks good. Well, there's a more efficient way to do this. You can just go to the end here and then like use the percentage sign, which teleports you to the closing bracket. Anyways, let's just do that, right? Okay. So now we have the cell, right? We have the cell. Let's save that. So now, if the cell is vacant, we just skip it. We just continue. We simply continue, right? So cell can be vacant, P1 owned, P2 owned, right? Now, if the cell is equal to cell dot P1 owned, else, right. So then if the cell equals to P1 owned, else. Okay, perfect. So now like we have these two cases, right? We have this case right here, and we have this case right here. So if so, like in these two cases, what we need to do is we have to populate like these cells, right? So now okay, so let's just say the current player. So what's that called? Okay, so if the game state what was that thing called? So if the game state's P1 turn, okay, so let's call it Boolean, right? Let cell is P1 owned, Boolean equals to this thing right here, right? We can just do that. Right? Let's delete this nonsense. So then if and then let to add to cell, right, equals, and then like if the cell, if this, right, if the cell equals, and then the game state, right, game state dot what's it called, okay, yeah, right, where am I? Okay, so now let's just say that this is true, right? Let's say that this cell, which we're iterating over, is player one's owned, right? If it is player one owned, if it's a P1 cell, and if it is, so let's say that this is true, let's say that this is true, and this is true, right? If they both are equivalent, they could both be true or false. Let's just say they're both true for without loss of generality by symmetry. If this is true, cell is P1 owned, and it's player one's turn, then it is the current player, so we add it to that, right? That makes a lot of sense. There are only 4 combinations, like true, 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 false, false, true, false, false, right? Very simple to brute force. Then it's clearly this, or else I presume it's that. I'll work through this just to this by intuition, right? And then to add to dot push cell, much more elegant than those 2 if else cases. Everything is more inline, right? That's it. That is all. Now, is this correct? Is what I've written correct? So if this is true and this is true, so if it is player one's turn and it's player one's cell, then we have to add it to the current player cell because the current player is player one. Let's say this is false, right? That means it is player two's turn, but the cell is like, let's do this is true, let's do this is false and this is false. Let's do, so we did true, true, now we're gonna do false, false, right? We're just gonna, so now it's player two's turn because this is false, and the cell is player two's cell, so it is the current player, player two, to do it. So we do it here. Now let's say this is true and that's false. That means it's player two's turn, and this cell is player one. So this cell belongs to the person whose turn it's not. It is player two's turn, and this player one's cell. So that means it belongs to other player's cell. Correct. And then pretty clearly the other case must be true. So if this is false, that means it's player two's cell. It's player two's cell, but it is player one's turn. That means this cell does not belong to the current player, so it's the other player. Okay, yeah, perfect. This looks really nice. So now we've built these two, and that's really the meat. And then from this, we have to just convert this to the binary, right? That's it. Wait. No, this is bullshit. Sorry, what am I saying? No, we don't care about the cell, because, like, the cell, right? The cell only has 3 properties, right? The cell only has, like, 1 piece of information, which can, like a, not a Boolean, but like a tertiary, a variable with 3 states. But it doesn't have the coordinates. Okay. So let's just do this, right? Like an integer, but I'm not sure TypeScript is integer type, right? Like, we have to add the actual coordinates, not the actually. Let's just actually initialize it, right? Well, let's just set this to a bunch of zeros, right? I'm just creating like what I want to do right now is I just want to initialize an empty, just an empty all zeros field. That's it. initialize empty 2D number array. Okay, this thing, same reference, right? In fact, I think the same principle applies here, right? Let's have empty row 1, empty row 2, right? Let's do something like that. And then like current player, just to make sure that like that these two like have different pointers. Like I don't want one change in one to reflect in the other, right? Very subtle bug that could really be very problematic. Dot push. And this will only push the this guys, right? It's crucial that I make this R2, empty row 2. So current player pushes empty row 1, other player pushes empty row 2. These are different objects. They're not shared. Okay, that's very important. I'd be so pissed off if that got me. I'm really grateful. Who's this person? Well, she could have saved a lot of trouble for me. Good hint. Okay, so then empty row 1 dot push just 0. And then it's the same thing here, but for R2, right? This looks good, right? For each of the rows and then for all the columns, right? Right, okay, yeah, that looks good. Okay. Instead of to add to, let's make this to mark, because we're marking it to mark. And then to add to the row and the column, right? To add to R and then C equals 1. It's binary. We're smart. Like initially it's all zeros, and then we set it as 1, right? And then what we want to do is let our input number array equal triple dimensions, right? Number of this, like 3 dimensions, correct? Sorry, that is the type, right? Equals to just a new thing of yeah, we can just copy this directly actually. For good measure, I'm just going to console.log this. And then return tf dot, what was it called, tensor? tf dot tensor on the input dot number array, right? I have to provide. Okay, how does that look? Let's run everything. Okay, there's some errors. Oh, I have to do that. Okay, let's do that. Bot.ts, line 4. Right, there's no default, because I'm going to add some more later. Okay, fair enough, fair enough. Okay, what else? Cannot find name. Okay, I have to import that too. So I have to import cell. Wait, no, what am I doing? Sorry. Yeah, right here. To convert the cell, we have to import the cell, right? From game state. Because it needs to like know this thing. Okay, let's just clear everything and do it again. I know there's some more errors. To add to. Cannot find name to add to. Well, we'll find it. Oh, it's to Mark. Right. We changed the name. Status. Okay. Let's just run everything. What? What is this? Oh, right. TensorFlow, no GPU. I think the issue was I had to delete this. Right, just TF-JS. Is that the fix? What? I have to delete that. Wait, was this error always there? Okay, yep, the error's gone. Nice. Time to look for some print statements, right? Let's delete this failure. Boom. Bot turn. Seems to be an error. This.cells is undefined. It should be GameState.cells. What am I doing? Okay, right, I understand. It's because of copy and paste error. Okay. .ts. Okay, good. Let's uncheck that. Go second, let the bot go. Okay. Okay. Again, we have like 1, 2, 3, 4, 5, 6. Like 1, 2, 3, 4, 5, 6, right? It's an array of 6, right? And each row, like we have 6 arrays, and each row in turn has an array of 7 elements, right? 1, 2, 3, 4, 5, 6, 7. A horizontal row, like 1, 2, 3, 4, 5, 6, 7, column 1 to 7. So that is our input array of all zeros, right? And then, and that's the current player. And then we have another one because it's an image stack. Like this first one is a top stack and this one is a bottom stack. Perfect. And then what's our shape here? Our shape is this is a tensor, which we're console.logging. Is 2 by 6 by 7, right? 2 by 6 by 7, which is precisely what we want here. 2 by 6 by 7. Okay, that's looking really good. That is very nice. Everything is going according to plan. Get status, clear, get diff. Okay. All right. I'm gonna take a break to use the restroom, but I'll first. Yeah, let's use the restroom. I need to finish my coffee and then get some snacks. And I'll drink some water. I'll take like a mini break. Yeah, I'll take a break. I'll be right back in like a minute or so. Use the restroom, take some water. Okay. Right, so I'm back. Right. Where was I? Yeah, I was looking at the get diff, seeing what I should save. Eat some chocolate. Okay, let's just, sorry, let me just clear that. Get diff. Okay. So let's see the changes. Let me just look at what's highlighted while I eat this. Again, the move we're getting is still a dummy move. We're just randomly selecting a move right now. We have yet to actually like do the prediction. Okay. I'm focusing on this stuff right here while I'm eating this. Just gonna create some entries, and now let's explore them. You can see a 1 here. 1 0 1 0 0 1 1 0 0 1. Yep. 0 0 1 1 0. Correct. I'm blue, right? Yep. I'm blue, and then red is the bot, right? So I'm blue, red is the bot. So let's look here, right? First, the top row is all zeros. Let's do this one, right? Let's do 0 1 2 3 4. The fourth one should have all zeros except 1 in the 6th index. What? 0 1 2 3 4, right? 0 0 0 0 0 1. 1 2. So then 6. Yeah. Point is second to last is a 1. Indeed, that is correct. Okay, this looks good. Now let's look at the last row, right? 1 1 0 0 1 1 0. So 1 1 0 0 1 1, and this is 0. But maybe like I forgot, but I'm guessing like it saw all these, and that's it. And then it chose this one randomly. Like when this function, like when this was printed out, at the moment we printed this out, like this one hadn't been filled yet. It just, yeah. And then it chose random. It randomly chose this one, I'm guessing. I should have remembered what happened. But the point is all these entries reflect like the previous turns. Okay, yeah, this looks good. Yeah, the point is that everything looks good. Get status. Get at all. Okay, lots of let me just okay, should I status? Okay, so everything is so now all that's left is to actually do this crucial thing. Sorry, what am I doing? Oh, well, what is going on? Okay, let's just quit everything. Get status, make sure I'm okay, fine. Clear, get status. Everything's nice and green, like I like to see that. We bot, let's just do a we test.ts and then bot.ts, right? Model.predict the tensor. That's it. .print. Okay. Now to actually the input looks good. We can kind of remove that. Then yeah, just model.predict input, right? That looks, oops, sorry about that. DW, not DE. Okay, yeah, let's just predict that. And let me just go back and undelete the other one, right? Via, what's that called? Net.ts, the other console.log statement we inserted last time. I do not care for that anymore. Comment it out. Okay, let's run everything. Alright, yeah, this.model. Sorry about that. Weebot.ts. 25 GG. This one right here. This.model. Run it. Nice. Fresh. Okay, go second, let the bot do it. Uncaught error. Got array with shape 26. Expect the input. Four dimensions. Oh, I think you need maybe like a wrapper around it, right? Like the first thing is like the batch, like for the batches, like the number of entries itself, right? Like we need a list, right? We need to add another dimension, right? Like remember how we saw a bunch of nulls in the model.shape? Like the null dimension, right? Like right there. Kind of like that, right? Now let's run it. Because again, like when we're doing model.predict, we have to do model.predict, like we have to do Sorry, let me stop this. Less the test.ts, right? Yeah, like you see how like when we're doing it, like we're kind of like wrapping it in, like it's like nested, like it's like the whole thing, right? Like there's like kind of implicit one because like they're like implicit brackets there, something like that. Run it again. Okay, this should. I don't know. I have a bad. Let's just see. Because I think that there's a transposition required. To be honest, like the number of channels have to be the third one. But let's just double check that. What? Maybe here, right? I'm just basically wrapping it up and delete these wrappings. See if that works. I mean, go second. Yeah, exactly. Transposition. Yeah, that's what I was thinking. I remember I used to see this error like in PyTorch. Like right, I saw this in Python before. What you have to do is a transposition, right? Like I mean, in PyTorch, I think this is correct. Channels are first, but then like in TensorFlow, it's like it's a bit unintuitive, but it has to be channels last. Channels transpose TensorFlow. Conv 2D layer. Channels last, right? Short input to channels last. I just saw this. Transpose input. Channels first, 2 channels last, right? No, I'm pretty sure reshape is wrong. You have to use tf.transpose. I don't want to change my model. I do not want to change my model. Yep. That's what I'm looking for. That is what I'm looking for. So 0, because we're keeping, okay, right. Because like I saw it somewhere else, right? We have like the first dimension is the samples, right? Like in this case, 1 sample, so there's extra wrapping. And then 3 means that like channels first. Wait, what? What? No, it'd be. It's the other way, other permutation. So 0 would be true, but then what would this one be? 1, 2, and then, wait, 3? Wait, sorry. Right, so like this one, right? Input number array in n chw, right? And then this one, right? Tensor equals to let's add that there, right? So that's like our input number. So then here, what we do is like we forge, right? tf.tensor of that, right? So then here we have this, right? And what we want to do is we want to take this channel here and put it there, right? Transpose of this guy, right? Okay. Exactly, the axis, right? tf.transpose. This is Python. Perm for permutation. Right, like you have 1, 2, 3 in the first row, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then you transpose it. Right now it's a 2 by 3, then it becomes a 3 by 2. Like you swapped it, like the dimensions, like you swapped them from 0 to 1 to 1 to 0. Like 0, 1, like everything is 0, 1, 2, 3, dot, dot, dot sequentially, and then you permutation that. Okay, yeah, no, that's perfect. Okay, so then the first thing's gonna be 0, but then, so then, like, again, like n and n max, so it's 0, 0, right? But this h, which is 1, goes to this one, h. So like this 1 is here, right? Like 0, 1, 2, 3, like n maps to 0, h maps to 1, w maps to 2, c maps to 3. N is 0, 0, check, 0. H, from 0 to 1, it's 1. It becomes here, like here. And this w, 1, 0, 1, 2, right? W is 2. And now a w comes to n, so the last one becomes 2. Like NCHW from NHWC. So let's see in my case, right? This is n right here, right? And that's n right there. So n is 0. So in the first, and then n is 0, and it goes to 0 here. It's in the 0th. Okay, perfect. And now, something like this, like 0, 1, no, wait, that's an extra one. Okay, so then we have to fill, so like this n is 0, right? But now c is 1, but it goes to the very nh, wait, number of samples, column, wait, is h? Height, right? Height and width, channels. Yeah, so height is for number of rows, basically. That's all I wanted to check. Am I doing this correctly? So what is, so like right here, right? This is like, that's the channels dimension, like 2 of them. That's like the first. But inside this, it is a 2 by 2, where the first dimension is the number of rows, which is the height, right? Anyways, this one, right? So like low battery, let's plug it in. So again, this like n goes to n, no change, 0. But then where does c go to? C is 1, but it goes to the very end. So last one is 1 then, right? Right there, right? Which is different from this one. Like we're going the other way actually. So 0, 1, so n is 0, c is the first axis, h is the second, 0 indexed. So h is 2, and now it goes to the second one, so the second one is 2. And this must be 3 by default. 0, and then c, and then w, the width, is 0, 1, 2, 3. But it shifts 1 to the left. So 0, 2, 3, 1, right? 0, 2, 3, 1. 0, 3, 1, 2. And if we kind of go from here to here, we should get back to original one. 0 to 0, no change. And then 2 kind of goes to the end. And then 1 goes till 0, 3, 1. I mean, I could actually build like the matrix here. It would be like a permutation of the identity matrix. Anyways, the point is 0 number of samples, then 2, 3 for the number of rows and columns. And then basically the point is we have 0, 1, 2, 3. And we just plop 1 to the end. That's really it. That's all that's happening. There's nothing. That's it. That is all. End of story, right? We just return this one and we're done, right? There's nothing more to it. But I want to like reverse that, right? So if you have 0, 2, 3, 1, like I want to like kind of use this to get back to it, right? So 0, 2, 3, 1 is 0, 1, 2, 3 now. So then let's just take, for example, this 3. This 3 here means the last one, which is this one. So 1. 0 is unchanged, and this one is 1, the first one. Well, the second one, if you consider like the 0 index. So that's the second one, the second thing, which is correspond to this, which is 2. So 0, 1, 2, and this must be 3. This one is the third thing, or the second last. From 3 is the last, second last. And second last from here is 3. So once I do everything at 0, 1, 2, okay, perfect. So these are inverse operations of each other. Okay, perfect. So that looks good. Let's quit, or let's go back there. And yep, indeed I removed the extra wrapping, console log prediction. So this looks good, right? Okay, yeah. Get status, declare. We run it. Huh. Okay, 56 is some error. We not.ts. 56. So current player cells, each entry is itself 2, so we just need another. Like we added a wrapper, but we forgot to do that. Innocent mistake. Okay, that looks good. Okay. Wait, is that, let me just clear everything, make sure there's no errors. Too cluttered. Okay. And now for moment of truth. Go second. Boom, the bot made a move. Well, no, we didn't predict it, but so console.log, right? What we're doing here, let's just see this. This is like the actual tensor. This is a prediction. Is this a prediction? I have to close it. Bot.ts, right? Yeah, we're actually logging the prediction. This is the prediction. Our neural network is doing an actual prediction. It returns 2 things, right? 1, 7. So the first entry, this must be our policy, right? 7, right? It's like 7 because 7 columns, right? What's the actual value? Data, wait, no, what? And this is 1, 1. How did I do that there again? Yeah, so like if I look at the test.ts, right? Then .print. Oh, we can just do .print. Okay, let us use do .print. Right? Actually, let me just get add everything. Status, declare, get diff. Yeah, the key thing is the transposition. Okay, get add all. Get status, declare, then whatever. Let's just do that. instead of console.logging it, what we'll do is we will do, I can't type, let's copy that there. I'm too excited. Get diff. So I uncommented the console. We just like use the TensorFlow's print method, intrinsic to the tensor. Let's run that. What? Oh, we have to do as TFW. We have to cast it. What? Wait, console.log logged it, right? Shape. What? What? So prediction right here is just the vanilla, just the normal array. Or each of them. Okay, so I think I see what's the issue. So instead of that, let's do prediction 0.print and prediction 1.print, right? Like that, maybe. Okay, this works. This works. This works. This does work. Because again, it's an array of tensors. Like it's an array. Like exactly, we have to actually index into it to get the tensor. Because like this object is a tensor. A second. Yes, 0, 1, 2, 3, 4, 5. So basically, everything has 14% chance of being printed, and then 0. So if I do 14 times, like if I do this number, right? It's like let's copy this number right here, right? Each thing has 14.3% chance, right? 14.3% chance times 7 columns is 100.1. If we actually copy the whole thing, right? Times 7, we get 0.99. So like basically, everything right here, all these columns have an equal probability of being selected. Okay, great. So now I just have to like incorporate that. And then this like gives you a value, which I assume means like 0. That means it's a draw because like the tan H is from -1 to 1. Very nice. In fact, this is probably like, yeah, this is pretty good. Now, once we train the network, like it will give higher values to central numbers because you want more central control, right? You don't want to like, this is probably the dumbest move you can make. Like this is the worst move you can start with in Connect 4 because it's furthest away from the center, right? Like you want to control the central columns. But anyways, yeah, 0 is correct because like initially from -1 to 1, like 0 means a draw, and then initially everything is equally balanced. Okay, this is really good. Let me just do a get status. Yeah, let's do get add all or get diff, see what changes I made. Yeah, I'll leave the print statements in there. Get status. Okay, so now how do we actually like extract these numbers from the tensor? Right? I feel like I'm almost done with it actually. Like the whole point right now, my main goal right now is just to like right now, like currently, yes, this is randomly generated. Like right now, if you look at our bot, right? Like right now, like it's still like we're still like creating a dummy move by like doing random, right? But what I want to do now is I want to actually take this prediction, and this prediction again is like a distribution over all the columns, and I can take argmax, I can just like, or I can randomly sample this. Like I can just randomly select a column based on these weights and like sample it. And then, or I can choose the one with the highest probability and I can just take that one, or I can sample them randomly. I think in training you randomly sample, and then in practice you just take the argmax of it. Problem is these are all equal, so I can just randomly sample it then based on these weights. And then like right now the dummy bot move, right? It selects a move from a random column index by like taking a random number and doing, yeah, this whole thing right here is the algorithm to do it randomly. But instead of doing that, I want to actually like use the zero, right? The first one to actually like, so I want to use prediction of 0 to actually get the move instead of randomly doing it. And once I do that, I can call it quits for now. Like, and once that is done, right? Once I'm actually using the network's prediction, that means that we've fully integrated the neural network with this game. And all that's left, and it's a substantial part, is to actually train the network, right? And that's where the AlphaZero, the Monte Carlo tree search with like the updated UCB upper confidence bound algorithm comes into place. Like instead of Monte Carlo tree search with the rollouts at the end, the rollout phase, we just replaced that with a neural network evaluation, which is why this article is such a wonderful article. But right now we're just kind of completing this step. We're treating this as a black box, just something that gives you a value in a policy. Right now we're only focusing on the policy to like get the game to work. We're just kind of like, once we finish this, we've integrated the network. I'm so close to integrating this connect for like the network with the game, and then once that's done I can set it aside and I can focus on actually training the network, and that's like where the actual fun part begins. We treat this as a black box network, we just improve it by using Monte Carlo tree search to actually improve our network, to make the network, the neural network, more and more accurate. Right now it's purely random weights, or maybe not random, but it's not random, clearly. It's like initialized to like zeros or whatever, but it's like, it gives me initial kind of, yeah, I want to make these better. But the point is, right now there's like two separate phases. Phase one is to actually build the skeleton, like the glue code, which kind of gives you like a game. Like this is like, once I integrate this, it'll be runnable, right? We can actually play it. Then we have to just improve the accuracy of the model. Like make it more strong, increase its gameplay, its game strength, and then we're done. So right now, all we have to do is like create this, instead of dummy, we'll remove the word dummy. It'll just be a bot move. And that bot move, instead of doing math.random, for like choosing or sampling a random column, we'll return the move based on sampling the prediction. And once I finish deleting this line and actually using this, then that means I've fully integrated the neural network with this bot. And that is a huge step, because then all that's left, and again, this is a lot, is to actually improve the model by using AlphaZero, the Monte Carlo tree search. But like once I get a strong model, I will have to not, like, there's no touching the game code. The game code will be basically kind of like almost crystallized. I think one thing left actually is to like filter out illegal moves, because like, let's say that this column is fully full, right? And this is a non-zero entry, right? Like what if when you sample it, like we have to like filter out and renormalize, right? Like we have to like, cause like if columns are full, then they're like illegal moves. We can't do it. So like, yeah, let me add a to do there, right? We bot.ts. To do filter out illegal moves and renormalize. In BumperCoins, there are no illegal moves, so like this is only connect for specific. Filter out illegal moves and renormalize. Illegal when bot is already actually on BumperCoins, like in terms of energy level, like you may not have enough energy to actually do the move. So yeah, that could be illegal. But I'm doing a turn-based. Depends on like 6 or 12 launches, like the launching strength. Anyway, sorry, I digress. The point is, I'll do it right now. Filter illegal when illegal when the column specified by the move is already full. So we filter illegal moves and renormalize. So, but for now, let's pretend that everything is, let's take the happy path. Let's assume that this prediction is fine, right? Okay. JS, let's just look at an example. I think they have classification examples, right? Overview. I can delete this, right? TensorFlow. Tutorials. Recognize hand, open in collab, sure, whatever. Failure model. How do I use the model, right? Do prediction, yes, make prediction. Model.predict. Preds. Argmax, highest probability. Okay, I guess the highest probability then. What is argmax -1? Output tensor class. Along the specified axis. Let's close this. What? Delete that. Delete that. Delete that. Delete that. Tells this. Delete that. What? No, undelete something. Okay. Delete everything to right of this, right? Wait, no. Delete that. Delete that. That. Yep, okay. I need to know what this argmax is along the specified axis. Or maybe not a sample. I mean, there's no need to do tf.softmax because like the neural network has softmax activation function in it. It already sums to 1. Okay, fine, tf.argmax, sure. Okay, so then let's copy this. Actually, no, I should filter the moves right now, right? How do I get the actual probabilities? tfjs, tensor, get raw data. Data sync. tfjs data sync. I have the documentation here, right? The data sync, right? Policy data equals to dot data sync, right? just console.log the policy data. I have to still filter it out, but okay, let's just see how that looks. Get diff. Okay, yeah, whatever, let's just run that. Exactly, so this thing gives me an array, right? Now what I have to do is let's pretend that the first column is all full. I have to remove that and then renormalize. And what is, wait, sorry, what is this? Float 37, float 32 array. Okay, so it's like a native, it's a native type to the browser. Okay, all right, that's nice. I'm gonna drink some water, I'll be right back, really thirsty. Okay. Right. Okay. So we have to filter out all the illegal moves, right, and renormalize. Okay. So what I think I need to do, right, is what I want to do is I want to like create a dictionary, like a map of like the column index and the its probability, right? Like map of column of keys being the column index and vowels being the probability, right? Basically like this is implicit, right? Like 0 is that, like 0, 1, 2, 3, 4, whatever, like 0 to 6, 0, 1, 2, 3, 4, 5, 6. Where like the index is the column index and the vowels are that, the filter, right? Or like, not a map, but like a, kind of like a list of pairs where a list of pairs, right? Where a pair of 0 is the column index, and pair of 1 is its probability, right? Something like that. Then sort this list of pairs with highest probs first. Highest probs first. Descending. Then keep delete, and then iterate greedily left to right, highest probs first, and every time that column is full, skip it until we reach a column index that's not full, and use it to use it as a move index and build the move and return it. Note that this process has to stop, because if it doesn't, the game must have already been overdrawn. Okay, now there's a leaf blower outside, which is really annoying me, so I'm just going to, I wrote a bunch of comments telling me the next step, so I'll just stop, I'll just end it right here. I'll commit my work. Claire, get diff. Yeah, okay. Then get add all, get status, get commit, almost finish integrating neural network into game, get status, get push. Okay, I'm pretty pleased with my work for now. I will end it here. Yep. Actually, wait, no. Let me first I just want to see this commit show up. Yep, I'm quite pleased with this. I will stop here now. Yep, that is all for today. That's all for now. I might do more later today, but I feel I've done good work. I should eat some lunch now.